Hello students, today we will learn how to convert a JK flip-flop to D flip-flop. We know the first step is to draw the truth table of destination flip-flop and the excitation table of the source flip-flop. So here our source is JK and our destination is D flip-flop. So we need to draw the excitation table of JK flip-flop and truth table of destination flip-flop. So let us start with the truth table of D flip-flop. So this is the table. Two values are there. One is 0 and 1. We know that when D is 0, Qn plus 1 is always 0, whatever Qn has. And when D is 1, Qn plus 1 is always 1, whatever Qn has. It doesn't matter. Similarly, we will draw the excitation table of JK flip-flop. So the four combinations are 0, 0, 0, 1, 1, 0, 1, 1. So we must remember the J column in excitation table, that is 0, 1, x, x. And just the opposite sequence is put in K. It makes our computation fast if we remember it. X, x, and easier also. X, 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 1, 0, x, x, 1, 0. In this way. Now the truth table and excitation table is ready. The next step is to make the conversion table. Let us start making the conversion table. How many columns will be there in the conversion table? That is D, Q and Qn plus 1. We'll start from the truth table. D, Q and Qn plus 1. Then J and K, Qn and Qn plus 1 column is common. So there will be total 1, 2, 3, 4 and 5 columns. D, Qn plus 1, J and K. D, Qn plus 1, J and K. So for the D, Z input 0, Qn 1 combination Qn have 0 and another D input 0 for Qn 1. Again D is 1 when Qn is 0 and D is again 1 when Qn has 1. Now we know that it's a trick that in D, Qn plus 1 follows the same sequence as the D input column. That is, it will be 0, 0, 1, 1. It will be same as it. Now we should check it. We can observe from the truth table that no matter what the Qn has, the value D is occupying will be put in the Qn plus 1 column. That is, when D is 0, the Qn plus 1 is directly becomes 0, and when D is 1, Qn plus 1 becomes 1. Now we will check this column Qn plus 1, J and K. With the help of excitation table of JK, we will put the values. That is, when for 0, 0 it's 0x. So for 0, 0 it's 0x. For 1, 0 it's x1. For 0, 1 it's 1x. And for 1, 1 it's x0. Okay, now the conversion table is ready. Now next step is to make the K maps of the last two columns, that is J and K. K map of J. And here the K map of K. Okay. So how many cells will be there before Qn plus 2 columns? So 4 cells will be there, D and Qn. Okay. So in the J column we can see 1 don't care, For D0 and Qn1. D0 and Qn1, there is one don't care. And one is 1 0. 1 0 1. And they don't care 1 1. 1 1, another don't care. So we'll impair a loop including 1. So thus J becomes, common number is 1 in the D table, that is D. KMF of K, we will check the K column. Don't care for both 0 0. So 0 0, it will be a don't care. 1 for 0 1. So 0 and 1, there is 1, and another don't care for 1 0. So 1 and 0, there is a don't care. We will pair a loop including the 1. So here the common number is there in this, no is common, only here the 0 is common for both the numbers, that is D bar. So K becomes D bar. Now it's time to draw the logic diagram. Logic diagram. The step is to starts with the block. We know here we'll put the source. We are converting JK to D. So here we will put the source, that is JK. So JK Qn bar. And J is D, K is D bar. So J will simply be D. And D bar will be the K. It's D and it's D bar. And the clock will also be there. Thus, the conversion of JK to D flip-flop is done. Thank you.